Hi everyone, this is Larry Feldman with a lesson on the distance formula. Let's say you had to find the distance between 2 points, but you didn't know the distance formula. Well, how could you go about finding the distance? Well, let's do an example in the first quadrant of the XY plane. I drew in point A at 5, 7, and point B is at 2, 3. And let's connect those points with a line. And we'll label the distance D. And D is what we're ultimately trying to find. So how could we find D? The way we're going to go about it is we're going to extend a horizontal line through point B like this, and then we're going to extend a vertical line through point A like this, and that leaves a point of intersection here, which I will label C. And you can tell that the coordinates of C are 5, 3. 5, 3. Now notice that segment AC lies on a vertical line, and the x-coordinates of all points on a vertical line are the same. So it should be no surprise that the x-coordinate of C is the same as the x-coordinate of A. Similarly, the y-coordinate of C is the same as the y-coordinate of B. Line BC, or segment BC, passes through 3 on the y-axis. So now we need to find the distance between A and C. And we don't need a formula to do that. All we do is subtract the y values. If the y value of A is 7 and the y value of C is 3, we simply take 7 minus 3 and we label that 4. This is distance 4. To find the distance between B and C, we subtract 5. We take 5 minus 2, which is 3. 5 minus 2. And notice that A and B, these lines, the vertical line through A and the horizontal line through B, intersect at a right angle because horizontal and vertical lines are perpendicular. Now we just use the Pythagorean theorem to find D. We take 3 squared plus 4 squared equals D squared. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. Taking the square root of both sides, D equals 5. So now we found the distance between A and B. Now how do we extend this to any 2 points? Let's start with a clean slate here, and I'm going to draw an XY plane again. But this time I'm going to choose 2 arbitrary points here and here. And let's say that this point passes through the x-axis here, and this point passes through the x-axis here. I can label this x value as x sub 1 and this x value as x sub 2. Now let's extend a horizontal line to the y-axis from this point up here and extend a horizontal line from this point here, we can label this value y sub 1 and this y sub 2. So this point here has coordinates x1, y1. And this point here has coordinates x2, y2. And connecting these 2 points, and finding the distance is the goal. So we want to find distance d. And all we need to do is follow the same analysis that we did previously. Namely, I'm going to continue to extend this line through this point down here. I'm going to extend it to the right, and we're going to notice that this intersection point does lie on a vertex that is a right angle, and we need to find the coordinates of this point down here. Let's call it C. So we notice that this point passes through x2 on the x-axis, and it passes through y1 on the y-axis. Now let's label this distance A and this B. Now notice, just like we did earlier, the distance between these points here, which we're labeling B, is y2 minus y1. So B equals y2 minus y1. And A is the distance between the x coordinates. A equals x2 minus x1. And we have a right triangle here, so we can apply the Pythagorean theorem again. A squared plus b squared equals c squared. Equals d squared in this case, because I labeled the hypotenuse d for distance. Now let's use substitution here. A is x2 minus x1. So I'm going to substitute this in here. Right there. x2 minus x1 squared plus, and then I want to substitute this b term in here. So we have y2 minus y1 squared, and I'm running out of room. That equals d squared. Now let me make some room so that we can finish this up. Looking at this equation over here, I can rewrite that with the d squared on the left, and I'm going to put the other terms on the right. And then I'm simply going to take the square root of both sides, and I'm going to be left with d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And as you know, this is the distance formula, and it is simply a derivation using the Pythagorean theorem. I hope that was helpful. Please check out my website, www.lfeldman.com, for links to my mobile apps, which contain hundreds of tutorials, examples, and solvers. See you next time.